everyone, so today we're going to be doing notes on multiplying polynomials. I just used the symbol for multiplying, but if you want to write out the whole word, that's fine. And this is section 7.2 and 7.3 in the textbook. I'm going to just combine it all together. So go ahead and pause this real quick and write down these 3 review problems, and then we will do them together. All right, so first off, you guys have learned all the different exponent properties before in the past. I just want to do a little bit of a refresher to recap the things that we're going to be seeing when we multiply these. So when we have the same base, the base here is x, and they're multiplied together, the exponents are going to get added. So this is like saying x to the power of 2 plus 3, or in other words, x to the 5th. Now for this one, I have x squared plus 3x squared. These are like terms because they both have an x squared. So here we have one of them, and then we have 3 of them. So together we have a total of 4x squared. And then for the last one, now we're multiplying together again. We have the same base of x, but then we also have these coefficients out in front. So what we do here is we have to multiply this 4 and the 3 together. So you have to multiply the 4 and the 3 together, and then we have that base of x. And then do we add or multiply the exponents? Good, you should have said add. So the power of 2 plus 3. So at the beginning, 4 times 3 is 12, and then x to the power of 5. So that's just a little recap on how we're going to treat these different exponents that we'll be seeing throughout these problems. All right, we're going to look at an example now. So the first thing we're going to do is a monomial times a binomial. So if you remember from our last set of notes, monomial means one term. So one term. And a binomial means 2 terms. So we're going to be multiplying 1 term times 2 terms. All right, so for this first example, 6x is being multiplied by all this stuff in the parentheses. So what I'm going to do is distribute the 6x to the first term and the second term. So when I do that, 6x times 3x squared, I'm going to multiply the 6 and the 3, which is 18. They both have a base of x, and I add my exponents. So an exponent of 1 and an exponent of 2. So 1 plus 2 is 3. And then the 6x times negative 4. 6 times negative 4 is negative 24. And then I just have the x. And that is our answer. Next one we're going to look at, now we have some more variables involved with this. So again, I'm going to distribute the 2x cubed to both terms inside the parentheses. Multiply my coefficient. So 2 times 4 is 8. And then x cubed times x squared. I have x, and I'm going to add my exponents. So 3 plus 2 is 5. And then 2x cubed times 3y. I multiply the coefficients. So 2 times 3 is positive 6. And then x cubed and y, those are not like terms, which means they cannot be combined. They stay separate. And I'm just going to write them in alphabetical order. So x cubed times y. And then I check if this can be simplified any further, which they cannot, because this has a base of x. This has a base that has x and y in it, which means we are done. And that's the answer. Now I want to give you a chance to practice a few of these on your own. So if you'd like to try A and B, go ahead and push pause. And then when you're ready to check your answers, push play. Next up, we're going to do a binomial times another binomial. So in other words, it's going to be 2 terms times 2 terms. All right, so we're going to do the same thing here with distributing, except now I have two terms that are being multiplied by this parentheses after it. So I'm going to take this 2x and multiply it by the first term and by the second term. But then I also have to take care of this 1. So I have to distribute this 1 to the 4x and the negative 3. Now this is actually something called FOIL. Some of you may have heard of this. I'm going to write this out. So FOIL stands for first, outer, inner, last. So let's look at that here with these little arches or rainbows that I drew. So first, oops, hang on. There we go. So first is the first terms multiplied by each other. So 2x times 4x. It's the first term in both parentheses. Then outer is the outermost terms multiplied, the 2x times the negative 3. Then the inner is the inner terms, the 1 times 4x. And then the last is the last term in each parenthesis. So that's just what is the word for it? An acronym for basically remembering to distribute everything. So first, outer, inner, last, or FOIL. So let's go ahead and look at that with this one. So 2x, first terms, 2x times 4x. Multiply the coefficients, so 8. And then x times x is x squared. Outer is the 2x times negative 3, which is negative 6x. Inner is the 1 times 4x, which is 4x. And then last is the 1 times negative 3, which is negative 3. And then from here, I look to see if there's anything that I can simplify. And there is. I have a negative 6x and a positive 4x, which are like terms. So I can rewrite this as 8x squared. And then I have negative 6 of these plus 4 of them. So I have negative 2x minus 3. And that's my answer. Let me actually draw a little bubble around this to make it stand out more. I don't know why my document camera keeps disconnecting. Sorry about that. All right, let's look at another example. So now, both of these look the same except their signs are different. So I'm going to do the same thing, the FOIL. So first terms from each. Outer, the outermost terms. I'm going to keep with different colors just to make it obvious what I'm doing. Inner is the innermost terms. Last is the last term in each parentheses. All right, so now when I multiply these, first, 2x times 2x is 4x squared. Outer, 2x times negative y is negative 2xy. And I do that instead of yx because I'm just keeping them in alphabetical order. Then onto the inner, y times 2x is going to be positive 2xy, again, keeping them in alphabetical order. And then last, y times negative y is negative y squared. So now here, when I look at my like terms, I have a negative 2xy and a positive 2xy. These are actually going to cancel each other out because they are opposites. So these cancel each other out. And I'm left with just 4x squared minus y squared. And that is our answer. Now for this last example, 3x minus 4 quantity squared. This is the same as saying 3x minus 4 times 3x minus 4. It's very, very, very important that you do not just distribute that squared. we have to expand it out and write it like this. So again, using FOIL, first, outer, inner, last. So first is 3x times 3x, which is 9x squared. Outer is 3x times negative 4, so negative 12x. Inner is negative 4 times 3x, which is negative 12x. And then last, negative 4 times negative 4 is positive 16. And then I have my like terms in the middle, negative 12x minus 12x. So when I combine those together, I get negative 24x. And there we go. Oops, I forgot to write the little squared symbol. There we go. Now I want to write a little note. Move that down a little bit. This is not, absolutely not, the same thing as distributing that 2. Don't ever do that. Please, please, please. Always write this out expanded as the 3x minus 4 times 3x minus 4. Now, another important thing that I want to note real quick about the FOIL, the first, outer, inner, last, is this only works when you multiply 2 binomials. So that fun little acronym only works when you're multiplying 2 binomials. It's just a handy or nifty way of remembering to distribute everything. All right, here's a couple examples for you to try on your own. So go ahead and push pause if you'd like to try some on your own, and then when you're ready to check your answers, push play. Now let's look at the last type that we're going to be multiplying, which is a binomial times a trinomial. So remember, a binomial is 2 terms, and a trinomial is 3 terms. So since it's not 2 binomials, I can't use the fun little nifty acronym of foiling, but I am still going to take that same idea and use it to make sure I distribute everything. That's also partly why I like drawing those little arches or the little things that look like rainbows, because then I make sure I get everything. All right, so first here, I need to multiply this x and this negative 2 by everything in the parentheses after it. So I need to multiply x by everything in the parentheses. And then I also need to multiply the negative 2 by everything in the parentheses. Now for this example, I'm going to write it in, I'm going to write out all the colors just so that you're able to keep track of what I multiplied a little bit more easily. So first, the first blue arch, x times x squared is x cubed. X times negative 3x is negative 3x squared. X times 7 is positive 7x. So I've finished with my first set of little blue arches, first term. And now I'm going to do the second term, the negative 2. So negative 2 times x squared is negative 2x squared. Negative 2 times negative 3x is positive 6x. And then negative 2 times 7 is negative 14. Now from here, you can choose if you want to underline things that are like terms, or if you want to cross them out, or if you don't want to do either of those options, that's totally fine too. I like to cross them out just so that I keep track of what I've used. So my first term is going to be the highest power, which is the x cubed. And then I have negative 3x squared and negative 2x squared, which gives me a total of negative 5x squared. And then I have the 7x plus 6x, which gives me a total of 13x. And then my last term is the negative 14. And that's my answer. Some people like to underline it. I do sometimes, depending how many terms it is. But I always do something to indicate so I know what I've used so far, because otherwise I usually end up missing a term, which you don't want to do. All right, now the second example I'm going to do with you, I wrote this the other direction on purpose. I put the trinomial first. So you have two options for how you can do this. You can either distribute the x squared to both of these, the x to both of these, and the 2 to both of those. Or you can do it in reverse. So distribute the x to everything and distribute the 1 to everything. I personally prefer to do it that way just so that I don't have the little rainbow arches that overlap with each other. That's just part of my own personal preference. But if you always like to multiply the first one by the second one, totally fine. But I'm going to distribute this x to everything, and I'm going to distribute the 1 to everything. No matter which way you do it, you're going to get the same answer. All right, and I'm going to do this in the different colors as well. So I'm going to start with blue. So multiplying x by everything in this first parentheses gives me x cubed. X times x is x squared. And then x times 2 is 2x. So that takes care of all my little blue rainbows. And then for my pink rainbows, I'm multiplying 1 by everything, which will give me positive x squared plus x plus 2. And then when I write this out fully simplified, my highest power is x cubed. So x cubed. And then I have x squared plus x squared, so 2x squared. And then I have 2x plus x, which is 3x. And then my lonely little plus 2. That does not have any like terms. And there we go. And again, I just want to reiterate, I chose to multiply the second one by the first one, but you could have multiplied it the opposite way. The first one times the second one and still should have gotten the same answer. All right, 2 last examples for you to try on your own. So if you would like to try a few of these, go ahead and push pause, and then when you're ready to check your answer, press play.